All right, welcome to Grade 9 Math. We're in Unit 3, Lesson 7, Solving Multi-Step Equations. In this lesson, our goal is to solve equations where there's a variable on both sides of the equal sign, and we'll be able to solve equations with more than two operations using inverse operations. Okay, when we're solving multi-step equations, we solve equations with more than one x term. In some equations, both the left and the right side contain an x term. When this happens, we cannot not use inverse operations. Since there are two x's that are each having different operations happening to it. In this case, we need to use the algebra skills to gather all the terms first on one side of the equal sign. To do this properly, remember this important rule. When you cross the equal sign, so if you bring one thing across the equal sign, the sign changes. So a positive would change to a negative, or a negative would change to a positive. So once you've done that, then you use your knowledge of adding and subtracting like terms to get to a single x term. Once this is done, you can then finally do your inverse operations that we learned last time. Okay, so I just want to make a quick change to my screen so that it's easier to write on. Okay, so we're going to see what we're talking about here. We have an x term on both sides. Okay, as you can see, x and x. So we can't isolate anything because they're both on one side. So what we talked about was when we cross the equal sign. So there's a way that we could, if we just was to sort of drag this over, the sign would change. And if I brought this over, its sign would change as well. So when I do that, then what was already waiting there was 3x. And now the x comes over, but the sign has changed. It's gone from a positive to a negative. The 4 is already parked over here. And when I bring this 4 over, it's gone from a negative to a positive. Now we can combine like terms. So we have 3 minus 1 is 2x, and 4 plus 4 is 8. And obviously what we need to do now, we finally see it as an equation, one-step equation, and we can do our inverse operations. So what's happening here is being multiplied by 2. So we want to divide by 2. So x is going to be 4. So I'm a little worried that the top part here is a little confusing. So let's take again, what if I was to do this with completely inverse operations? So I would have 3x minus 4 equals x plus 4. And if I want to, the next step I'd want to take away the two things that I don't want on those sides. So on one side, it's 3x minus 4 equals x plus 4. But of course, what did we take away on this side? We want to get rid of one of the x. So what we do on the right, we must do to the left. And what we didn't want on this side was the negative 4. So we need to add 4. And on this side, we would also add 4. So as you can see, yes, this is probably the proper way to show it, but we did learn a nifty trick over here that we could use. So then going forward, the 3 minus 1 would still, like if we clean that up, the 4's are gone, and on this side, the x's are gone. So in a way, by doing all this, we got to the same point as we did in one step here, we did in 2 steps. So it's a little faster if you want. And then the ending is the same. Okay. So just something for you to play around with and make sure you feel comfortable with one of those methods. All right, right here. Sometimes it gets a little more complicated. So when one or more of the x terms are in brackets, first we use the distributive property to remove the brackets. Then you can move all the terms to the same side. So here we go. We're going to multiply things into the bracket. So 3 times 2 is 6x. 3 times 5 is 15. Don't forget that second time. I always see kids forget. They do it to the first one, and they forget to do the second distribution. That's the whole point of it. Otherwise, it wouldn't be very helpful. Okay, we have like terms. So let's do the dragging method. So I can bring this one over, and I'm going to bring this one over here. So we're going to get the x terms on the left side, the non-x terms on the right side. So what happens is I still have my 6x here, and when the 4 comes over, now it's a negative 4x. The negative 1 was already waiting, but when I bring the 15 over, it's now a negative 15. Now we just solve like we have before, combining like terms. 6 minus 4 is 2x, and negative 1 minus negative 15 is negative 16. Okay, now we finally get to the point where we can do the inverse operation to solve for the x. So divide both sides by 2, and we get negative 8. Very good. Sometimes it would be good to check. So check if our answer makes sense. Left side, right side with a t-chart. On this side we had the 4x minus 1. On this side we had the 6x plus 15. Of course, we're going to put the 8 in for the x. So 6 times negative 8 plus 15, and 4 times negative 8 minus 1. Well, we're going to get negative 48 plus 15. And we're going to get negative 32 minus 1. So 33. So negative 33 on this side, and negative 33. And we know that we are correct. When our check is equal on both sides, that tells us we're correct. So while it doesn't matter which side, left or right side, you move the x terms to, it can be helpful to try and move them in such a way that the coefficient of the x term is always a positive. Now we didn't have to worry about that here, but certainly the 6 being a larger number, it made sense to bring the 4 over. If I would have brought the 6 over, we would end up with a negative on this side, and we can still manage that, but it just makes things unnecessarily harder. So maybe one of those will come up in the next little while. We'll see. Let's say I have multi-step equations. When solving multi-step equations, these are equations that require more than 2 operations. It is very important to keep track of the original operations that happen to the x, so that you can do the inverse operations. All right, so why don't we, like we did when we started this, we talked about layers and what's happening to, what are the functions happening to the x. Well, the first thing that's closest to the x is it's being multiplied by 4. The next thing closest to the x is it's being added by 15. It's Kind of cool to do maybe a different color. And finally, the third layer of this, I don't know what color to pick, pink here, is we are being divided by 3. Well, of course, we will have to do this in the opposite order. So first thing we're going to do is multiply both sides by 3. Then we're going to subtract the 15 from both sides. And then we're going to divide the 4. So let's get to it. All right. So I've said in the past, you want to make a big bracket. So 3 with a large bracket, 4x plus 15 over 3, the large bracket, equals 3 times 11. So there's this is better to cancel early. Okay, we could distribute this in, but listen, it won't make any time saving for you because you'll just get 12 here, and then you'll end up reducing 3 into 12 will get you the 4, right back to 4. Here you'll get 45, but 3 divided by 45 will just end up with 15. So if you can recognize to reduce these early, that will go a long way in helping simplify. Okay, so once we do that, we have a 1 in front. So 1 times anything just opens up the brackets. Okay, 3 times 11 that's easy, 33. All right, so we did our first step. Our second step says subtract both sides by 15. Okay, so we could jam it in there, or we could go underneath if you want to save some space. Okay, and so that's going to eliminate. So we have 4x equals, now this is more negative. So negative, well, 33 and 15 is 48. All right, and our last step is to divide by 4s. X equals negative 12. 4 goes into 48 12 times. And then we're done. So, very good. All right. So, when we get to example 5, we can see that we can represent a problem with a perimeter, for example. So if we can make a perimeter equation work for us, we can solve for that. So the perimeter of this triangle is 25 centimeters. So all around would add up completely to 25. Write an equation, then solve it to find the n value. So n is like some variable in scaling length, but we don't know what it is. It's some variable that scales the triangle bigger or smaller. If we change that, it would change the dimensions, but whatever that may be. So let's just start off. How would we even start with a perimeter? So a perimeter on its basic form is a side plus a side plus a side. So I have side 1, side 2, side 3. So side 1, side 2, side 3. So if we were to substitute all of those, what would we think? Well, the other thing we know is that P is 25. So we can go ahead and put 25 in here. Okay, and we can say that S1 is 2n plus S2 is just 5, so no n on the 5. And S3 is 4n plus 2. Oh, why did I put 3? 2. All right. Well, there's nothing in front of this. So the first thing we'd want to do is check. If there's something in front of here, we have to distribute. If there's just a 1, we just drop the bracket. So 25 equals 2n plus 5 plus 4n plus 2. All right. Well, we look for like terms. Those like terms are there. We might as well keep that on the right side. And then our 2 can come over, and our 5 and our 2 can come over, and they'll switch signs. So 25 is already parked over there, minus the 5 because it's the plus becomes a negative, the 2 becomes a negative. And over here we had the 2n plus the 4n. I guess we could have added that up, and that would have made our job easier. But so we have 25 minus 5 is 20. 20 minus 2 is 18. And 6n. All right, so what's happening at the end? It's being multiplied by 6. And we have to divide 6 by both of those. So n equals 3. So whatever n represented, it is equal to 3. Now I just want to go back and make sure I didn't miss something. I feel like video meeting. Thank you for dropping in, and good luck on your practice. Remember that I've assigned lots of mathletics practice that you can also work on if you like the virtual online practice exercises. Have a good day.